So I wanted to thank Rob Hall particularly because he was the chief scientist for TARSAN, and he put this presentation together. And Tiago and Yishi are the postdocs who are working on the project with us. Anna, obviously, and Lars, I'll mention later on. And Rob Templeton, who I see is here, and the ALR team. I'm sure if I say something really stupid, they will correct me, but I've got some slides that Rob Templeton kindly agreed for me to show just about the capability of ALR. So in many ways, this is kind of overview of the whole TARSAN project. So the cruise was earlier this year, as you heard from Anna, and this is the great team who are on board. I wasn't on board myself, but it brought together several different projects. And as Anna said, we should have got to Thwaites. The whole goal of this project, the TARSAN proposal, was that we have got moorings through the ice, so things measuring the atmosphere and the ice properties, and below into the cavity below. So we have these Amiga stations, but unfortunately they're on Thwaites, and our hope was that we would send the AUVs towards the Amigos. But obviously we weren't able to get there. So kind of following on from your last questions, Guy, like Anna, we would like to go back there to actually get to Thwaites. But nonetheless, Dotson is really, really interesting and easier. So what you're looking at here are is the ship track. So most of the work was done around Dotson, and all of the ALR missions that I'm going to talk about were from Dotson, like for the Hugin. And obviously we've got good CTD, lowered ADCP from the ship, and we were able to do this while the AUVs were in the water. And we also have turbulent mixing at the boundary between at the edge of the ice shelf. So the project is very much putting all of these platforms together. And this figure I thought was worth showing you. I know it's from the ship. It's the section along the ice front of Dotson. The top panel is the temperature and the bottom is the velocity. So we can see the blue bit at the bottom is the inflow of the warm, deep water that we were particularly interested in, and the red on the left-hand side is the meltwater heading north again. And from Anna's Hugin, you heard about how it was mapping the depth, the underside of the ice shelf, and that's really useful for us because we can use that data, and that's what the pink line is, which is the best estimate of the ice draft just under the ice shelf from the Hugin data. So it's really useful for us to show that it's much thinner here where the outflow is. Obviously it's melting, and so the combination of the Hugin and the CTD sections, ship sections, are really useful. I know we're meant to be talking about powered AVs, but for us in TARSAN, one of the goals was using lots of different platforms all at once and using them for their strengths. So the ship-based surveys, the AUVs, but also gliders. So we have very high resolution sections along the front of the ice shelves, for example, and going into the polinia and the boundary currents from 6 ocean gliders. So when we're going to be looking at the science from this project, we won't just be looking at the AUVs themselves, we'll be bringing the glider data in, or the ship-based data in. And so we've got more than 1,000 profiles, or double that profiles, 1,300 dives, which is 2 profiles during the campaign, even though it was relatively short. And the other autonomous underwater vehicle, they were seals. So we tagged seals, and although they don't give you the high resolution that the powered AUVs do, what they are giving us are measurements over the winter time. So for us, that's critical. This is such an inaccessible area that we were only there for a month or so. So for the rest of the year, we have tagged seals, which are giving us CTD profiles. And the figure on the left shows where they were, and the figure on the right is the temperature at 450 meters. Whoops, 450 meters. So these are the warmer waters going towards Dotson ice shelf here. So now on to the Autosub long range family. And thanks again to Rob Templeton, whose slides these are. So just to give you an idea of the look of them. So this is the Autosub long range 6000, which has a 6,000 meter depth rating, and gives you an idea of the size here. And as befits the name, Autosub long range, or boat face if you prefer, long endurance. So compared, as Anna said, the Hugin and the AL are very complementary to each other. And to my mind, at least, the Autosub long range family are kind of positioned halfway between gliders and things like the Hugin. So they're a little bit smaller than the big AUVs. You can put them over the side, much like you would a glider. They can be out for long endurance. They don't necessarily have the capability to have very high payloads. So lots and lots of sensors and things like the multi-beam that Anna was showing us, we don't have on the Autosub long range that we were using. And everything, just like a glider, everything is down to the weight of the payload, because if you have lots of sensors, lots of payload, then you would have fewer batteries, so that would reduce the range you have. So the one that we were using, as far as I can remember, I hope I get this right, is Autosub long range 1500, which obviously has a depth rating, and that one has even greater endurance and range. So 3 months and could go for 6,000 kilometers. I should say we weren't using it for that length of mission in this campaign. Great that they're now being able to be using rechargeable batteries. I say that as somebody who spent several hours carting those great big batteries back and forth when we had to change them at sea. So Anna was talking about the navigation of the Hugin, and obviously the navigation is kind of crucial. You want to make sure, A, you knew where your ALR was when it got its measurements, and you want to make sure you get it back. For ALR 1500, they've upgraded a lot of the compass systems, and this terrain-aided navigation capability is, as far as I know, still in development. So that's somewhere that future will go. Having said that, for going under ice shelves, I can't see that we'll necessarily have good bathymetry unless we've sent a Hugin out there beforehand. But maybe that's another way the two AUVs can complement each other. So this, I thought this is kind of nice because it gives you a sense of scale. So you can see the people, you can see the large Autosub here on the left, and then you can see the Autosub long range here on the right. So you get a sense that it even looks halfway between a Hugin class of vehicle and a glider. So pros and cons, of course. So this is the ALR that was used for TARSAN. So the sensors that we have upward and downward looking 300 kilohertz ADCP, very similar to Anna's on RAN. And I'd love to talk to you more, Damien, about that. we had turbulent mixing. So these probes at the front are microstructure probes. So we're very interested in the turbulence happening under the ice shelves, and that would link in again with the roughness estimates that Anna got from the Hugin. There was CTD, dissolved oxygen, fluorescence, and turbidity for dissolved sediment and the meltwater signal. And the one we had a 13-day endurance, but we didn't use it for anything like that, and like as long as that. Forward-looking altimeter for obstacle avoidance, and we heard from Anna how critical the obstacle avoidance is. So that altimeter has, at least on previous Autosubs, been fairly crucial for getting the vehicle back safely. And there are various command and control systems that Rob Templeton would tell you much more about than I would. So here are some data from the Autosub long range, and this was a mission that was going in under Dotson ice shelf. So if we look at this bottom left panel, the thick black line that my cursor is on at the moment is the edge of the ice shelf. So open water to the north, ice shelf to the south. And so this is a relatively deep trough going in. And Wonsang Lee's on the call as well, so he would be able to fill in the details, but the Arion was in the area at the same time as we were, and they had the intention to deploy a mooring through the ice shelf of Dotson, and so it was a little bit fortuitous in a way, in that we were there at roughly about the same time as they were, but also we kept talking because of this forum. And we managed to find out the location of the drilling, the mooring that they were drilling a hole for, and that's here, marked in pink, the melt mooring. And so once we knew that location where they were working, we sent the AUVs in to survey that area to provide a bit of spatial context for the results that the MELT project and Wonsang Lee's project will get from that mooring. So it was actually very exciting that we were all there at the same time, and we hope very much that there'll be some interesting science to come out of comparing the mooring with the AUV. So similar kind of thing to what we had hoped to do under Thwaites in the first place in the original proposal. So with ALR, we did 12 missions, about 250 hours, of which about 90 hours were under the ice. And that's the bit I'm focusing on here. So the bottom left is the temperature, and we flew it so it was about 100 meters from the bottom, from the seabed. So mapping the warm deep water going in under the ice shelf. And you can see relatively warm waters here going in. There's not an awful lot of pattern of structure in it, on this color scale at least. And then the middle and the right panels are from the ADCP, and we at the moment only have a single bin from the ADCP provided by the ALR team, and these are, as I understand it, corrected for the motions of the ALR, as we were hearing in the discussion between Anna and Damien. But at the moment we only have that single bin. We don't have the whole profile. So we're talking with the ALR team about how to get that whole profile, the upward and downward looking profile. But there's some interesting structure in these. So this is the zonal velocity, and you can see westward flow going here, and So maybe there's a circulation here, and some similar interesting looking flows around here. And if we look at the right-hand one, this is the meridional velocity. And again, we can see some quite interesting circulations going on in this trough. So like Anna, we've only recently got data back, and this is very much work in progress. But we're very much looking forward to looking at all about what this data is going to show us. And my final picture is a sort of Tiago's attempt to kind of show this in a 3D sense. This is the thick black line is the front of the ice shelf, and this is latitude going into the ice shelf to the away from us. And these are the paths of you can kind of see here, it's colored by temperature, but you can see the AUV, some of the missions where they were starting at the surface, going down and then into the ice shelves. And you can see the very colder waters near the surface, the winter waters, and the ice shelf melt waters, and the much warmer waters at depth. So, like Anna, lots of interesting data to look at, not enough time yet, and to look at them in as much detail as we like, but we're looking forward to working with the other TARSAN people in the team, and also with Wansang and Anna's team. I think that's it.
Lovely work. Thanks, Karen. That's, again, really exciting talk. And yeah, lots of questions come to mind. But I'll just see around if there's any other hands going up in the meantime. I guess it's hard because you weren't necessarily there, but you've had a lot of feedback from the people. You know, were they overall very happy with the performance of ALR?
Yes, very much so. I mean, Rob Templeton's on the call, and he was responsible for it. But yes, I mean, #1 success. It came back. That's great. There were some nervous moments, as there usually are with AUVs, but you know, the data look great. I don't think we've even started looking at the turbulent mixing data, but that can be really exciting.
It seemed like, yeah, the sea ice conditions stopped you getting into the thwaites, but would I be right in saying you had pretty good conditions? It seemed like the number of days of operation maximum that you'd expect in Antarctica with weather. Did you have weather events that shut you down, or?
Maybe Anna is better placed to answer that than me, because I wasn't on board, but I think it was, I mean, apart from the sea ice, which wasted a little bit of time because it had to go a long way round to get in, and obviously didn't get to the target sites, but I think it was remarkably little downtime.
Yeah.
Is that right, Anna?
No, there was some things that could be done even in rough weather, like UUCTDs. So when the weather was, when it was too windy to do other stuff, we went and did UUCTDs. So there was always, I don't think we had any complete shutdown days at all, actually.
I mean, certainly from our point of view, it was absolutely astounding how much was achieved by that cruise in a relatively short time. And I think one of the lessons that I kind of want to take forward from it is having all of those different instruments each with different strengths, so gliders and seals and ship and 2 different AUVs. You know, they're all different, and having them all together was great. And then if one was having difficulty, you went and did some gliders, or if the gliders were having difficulty, you do some yo-yo CTDs or whatever it is. So having them all on board was great.
Yeah, fantastic. And it's so true. Damien's got a hand up. I'll go with Damien.
Thank you very much. Yeah, really cool as well. I'm just wondering if you, Karen, or Anna, if you're going to look at any of the backscatter data that you have from the ADCP or the multi-beam, particularly in association with the productivity data that you have, you know, any signs of crystal Orpheus in there? I know
That's a great
bio isn't the
question.
main.
We don't have anybody with that sort of interest in our team. So, so yeah, if you're offering, Damien, it would be really interesting, wouldn't it? You're absolutely right. It would be really interesting.
I'd love to talk. Yeah, I mean, if we have a conversation about ADCPs, I'd love to talk about backscatter as well.
Mm-hmm.
Particularly because you have the multi-beam and the ADCP on the RAN. You know, being able to look at coherent targets in both, yeah, would almost allow you to do some target discrimination under ice.
It sounds great.
Steve Nichols would be delighted to hear about that.
Maybe we can have a small workshop before Christmas or something. That would be great. And I think also with ALR, because there are two, and that's a third. They overlapped. We have some overlapping very near in time and also in space. So that would be great, I think.
The only thing I've ever been able to find in that domain is, I think, 12 years ago, some Australians put a drop camera down through a hole in the Amory and saw a krill, on a camera, and that's about the extent of it so far. So this would be just light years ahead of that.
No, that would be fantastic. Really I absolutely great suggestion. Yes.
Cool.
Thanks, Damien. I think Anna, you've got your hand up.
Yeah, I just wanted to fill in a bit that I agree totally with Karen. It's great to have this these many things on board. That's the reason why we could do, why it was so successful, and we are still only QCing the data. There's so much data. But the other thing is that I think Rob Hall, who was cruise leader, he aged a bit during the cruise. I think it's also one thing to take away is that it puts very big demands on the cruise leader when you have so many different vehicles, and maybe it's good to have a designated cruise leader that only works with coordinating the things that happen on the cruise.
Yes, I think that's a really good point, Anna. And yes, he did. He's only just recovering, poor guy. And I think that's a very good point. And I think probably one of the lessons that we've learned would be to have sort of a bit more team, making sure that somebody is in charge of the gliders and somebody's in charge of the ALR missions who isn't a scientist, who isn't the chief scientist, because it's a huge job. This was a massive cruise. Not only the Tarzan that we're talking about, but also there was another project called Artemis on board, and the coring guys, the Thor guys. So it kind of mushroomed from the original idea, and that was very hard.
Oh, that's very good points. And I guess, if you're running 24-hour missions or 24-hour operations as well, you probably need two people.
Yeah, it was tough. It was I wasn't on board. It was tough enough piloting the gliders, which is what I was doing.
Can I ask a question? How close did the two AUVs get to each other? What was the closest proximity in time or space?
We should get that. They were very close. We were both at the same time under the ice shelf. And do you remember, Rob? I thought maybe we even planned so that they would overlap, so we would have some calibration. I know we discussed it, but it was very close. Yeah, me neither. But we can check that. Good question. Yeah.
All right, I can't See any more questions? I'll just, yeah, thanks again. Well done, Karen. I'm really excited to see that mission which actually reached to the mooring location. I think that's a big achievement in terms of one of the sort of dream goals that was always thought up ahead of time. But so that's really, really exciting, and that'll obviously lead to more adventurous on ice, through ice, under ice objectives into the future. And thanks, Karen. So I think we'll look to wrap it up there, unless there's any more questions. No, okay. Well, thanks everyone for coming along. Wansang's just had to leave, so I'll say his apologies. But yeah, very, very grateful for everyone turning up that turned up today. Sorry if there was a bit of late notice in that announcement. So appreciate everyone turning up, and again appreciate both Anna and Karen for the great talks. And very excited about, I guess, you know, the platform that you've now pushed forward for everyone for future work. It's exciting. You know, there's a lot of risk, and what you've achieved this last season pushes everyone forward and helps the funding agencies, helps the research programs, you know, take more risks into the future as well. So that's, yeah, couldn't be more excited. Well done. All right. Thank you, everyone. These talks will be available online, I believe, through the SOOS YouTube channel. And if you want to get in touch with any of the TARSAN members, please just reach out through the SOOS webpage, and we can go from there. All right. Thank you very much.